Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on part 3 of a 4-part series on algebraic functions for mathematics grade 10, and that is the hyperbola. In part 1, we looked at the straight line graph, and in part 2, we did the parabola. In part 3, which is this part, we're going to focus on the hyperbola. And in part 4, we're going to look at the exponential function. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 4 of this 4-part video series. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Now back to the video. In detail, we're going to look at number 1, functions of the form y equals to 1 over x, which is the most standard basic equation of a hyperbola you'll ever draw. Number 2, functions of the form y equals to a over x plus q, which is a hyperbola that has been shifted about the y-axis, either up or down. And we're going to look at the effect of q and a. Number 3, we're going to be discovering characteristics, which is your domain, your range, your intercepts, and your asymptotes. Number 4, we're going to be sketching graphs of the form y equals to a over x plus q. And number 5, which is the last one, we're going to look at how to find the equation of a hyperbola. We have a lot to cover, so let's start. Starting with functions of the form y equals to 1 over x, which is, like I said before, the most standard basic equation of a hyperbola you will ever find. Let's say you are given this example and they say to you, sketch the graph. What to do is you draw up a table. In that table, you're going to have this figure 0, quarter, a third, half, 1, 2, 3, 4. And on the negative side of the 0, you do that negative quarter and so on and so forth until you get to negative 4. Now, let's find the corresponding y values for these points. When x equals to 0, we've got 1 over 0. 1 over 0, that is equals to, it's undefined. Let's change this into my favorite color, which is undefined. And when it's undefined, what happens is that when it's undefined, you write that on the slot. You go when x equals to 0, y equals to undefined. When x equals to 1 over 4, this is the scenario you have. You got 1 over 4, which we know is equal to 1 times, and you flip the fraction at the bottom upside down, so that becomes 4 over 1. 1 times 4 over 1 is equals to 4. So that will be equals to 4. Okay, let's remove this. That is equals to 4. Same scenario happens for when you've got your x equals to 1 over 3. That answer over there will be equals to 3. And for 1 over 2, that will be equals to 2. For 1, it's very simple. You've got 1 over 1, which is equals to 1. And then for 2, also very simple. 1 over 2 equals to half. And that's what you have over here. When x equals to 3, you've got a third. And when x equals to 4, you've got a quarter, which is what you have over here. Now let's look at the negative side of the x-axis. When x equals to negative a quarter, it's almost the same as when x equals to a quarter, just that it's negative. So we've got negative 4, negative 3, negative 2. Take out a calculator if you don't believe me and calculate this yourself. Negative 1. And on the other side, we've got negative half, negative a third, negative a third, and the last one will be negative a quarter, negative 1 over 4. Now let's plot these points on the Cartesian plane. Here's a Cartesian plane. Okay, let's change the color and make it red, so it matches the type of graph that we want to draw. Y equals to 1 over x. So when x equals to 1, y equals to 1. When x equals to 2, y equals to half. When x equals to 3, y equals to a third. When x equals to 4, y equals to a quarter. And that's how you plot the points there. Now on the other side, between 0 and 1, when x equals to half, y equals to 2, that's where you plot the point. When x equals to a third, here is a third is over here, between half and 1, and a quarter. So that's there, it's equals to 3. So it will be right there in the middle. When x equals to negative a quarter, then y equals to 4. And that's the point that we plot there. Let's do the same on the left hand side. On the left hand side, this is what we have. When x equals to negative 1, your y equals to negative 1. When x equals to negative 2, your y equals to negative a half. When x equals to negative 3, your y equals to negative a quarter. A third, I mean. Negative a third. That's what we have there. And when x equals to negative 4, you've got negative of a quarter, which will plot that number out there. Now, between negative 1 and 0, we have negative half. When x equals to negative half, y equals to negative 2. There is negative 2. When x equals to negative a third, y equals to negative 3. Right there in the middle. When x equals to negative a quarter, y equals to negative 4. I'm going to plot out the 4 there. Now we join the points. Let's join the points together. Let's start with the ones that we started with. Okay, when we join the points together, that's how we join the points together. Now, we continue with the tails. So it's going to go towards, okay, it's not straight, but that's how it goes. It never touches, but it tends towards the axis. Never touches. It goes towards the axis, but never touches. That's a better one. Same story on the other side. Let's join the points together. Let's join the points. Now that the points are joined, now let's draw the tails. The tail on this side will go, okay, and on the other side it will go that's how it goes. And that's what the graph is going to look like. Obviously, we're not going to draw it accurately because the tails are a bit tricky to draw, but this is what the graph calculator showed us, meaning that we got the graph very, very, very correct. Now let's look at functions of the form y equals to a over x plus q. And we're going to look at the effect of q. We know for now already that the effect of q is such that you're shifting it up and down. This is the graph of the equation of a shifted hyperbola up and down. Now when x is equals to 1 over x, that means your q is equals to 0. That means you haven't shifted it about the x or y axis in any way, shape, or form. It's not shifted. Now what happens is that you've got your reference line. Your reference line will be right in the middle at x equals to 0. At y equals to 0, I mean. Where your y-axis equals to 0. That's where the reference line is going to be. Let's change the color. Make it thicker so you can see it. That's the reference line. Notice that your graph never touches this line. Where x equals to y equals to 0. Or the x-axis. Now what happens when y equals to 1 over x plus 1? That means the graph has now been shifted 1 unit up. And the graph of 1 over x plus 2, that means the graph has been shifted 2 units up. Now let's draw the graphs. Let's draw the lines of reference so you can see what we are talking about Let's make this one blue. Let's make this one blue so it matches the blue graph. There. That's 1 unit up. It's on y equals to 1. And the other one, the green one, is on y equals to 2. That's how it has been shifted. Now, when your y equals 1 over x minus 1, meaning that your q is equals to -1, that means your graph has been shifted 1 unit down. When y equals to 1 over x minus 2, that means the graph has been shifted 2 units down. So now let's draw the lines of reference for that as well. That is the line of reference for the purple graph, which has been shifted 1 unit down. Let's change the color to purple. And we've got the last one, which is black. Let's change the color to black. And that's how you find the reference point for when your graph is shifted up and down. Notice that for the black graph, the line does not, it just gives you a perspective instead of, so that's almost like shifting the x-axis down and up. And that's the effect of Q. The effect of A, on the other hand, is such that when your A is positive, for example, the red graph, the blue graph, and the green graph, your pieces of the equation are going to be on the first quadrant and the third quadrant. If you were to number these quadrants, this is how they will be numbered. This is quadrant 1. This is quadrant 2. That is quadrant 3. And that is quadrant 4. Now, when your A is positive, your graph will be on quadrant 1 and quadrant 3. And when your A is negative, for example, in the purple graph and the black graph, then it will be on the second and fourth quadrant. That's the effect of. Now let's discover characteristics. Now your domain is all real numbers, except for when your x is equals to 0. That's the only one. That's the only place where it is undefined, so it is excluded. It's a restriction. The range is all real values of y except for where y is equals to q. Notice that even on the shifted graphs, your y never touches, your graph never touches the point, the line q. Y equals to 2 for this example. For the green graph, it never touches. It never touches your x equals to 0. And it never touches whatever q you've shifted it by. Moving on to that, the asymptotes correspond with your domain in the range. The horizontal, which is up and down, is y equals to q. That's the horizontal asymptote. And the vertical asymptote, which is the left and right, is x equals to 0. Notice that the vertical asymptote is almost identical to your domain, and the horizontal asymptote matches with your range. Now the x and y intercepts are very easy. They are exactly the same way we've been finding them all throughout. For the x-intercept, you make y0, and for the y-intercept, you make x0. Now, this is how you sketch the graphs of the form y equals to a over x plus q. You first figure out what the sign of a is. If your a is positive, let's change the color. If your a is positive, if your a is positive, right, then you have your graph on the first and third quadrant. When your a is negative, your graph will be on the second and fourth quadrant. Now the y-intercept, that's what you find next. You just make x0 to find the y-intercept, and to find the x-intercept you make y0. Right, and then you find the asymptotes. Remember, the horizontal asymptote is y equals to q, and the vertical asymptote, which is the left to right, is x equals to 0. Now let's look at example 2. It says sketch the graph of g of x equals to 2 over x plus 9 plus 2. Mark the intercepts and the asymptotes. Let's first figure out what our a is. Now once you work out your a, it makes everything easier to work with. Our a equals to 2 in this case, which is positive, meaning that our graph will be on the first and third quadrant. Our q is equals to 2, meaning that therefore the horizontal asymptote up and down, the horizontal asymptote will be y equals to 2. And then the vertical asymptote is very easy, doesn't change. The vertical asymptote is x equals to 0. Right, let's find the y-intercept. To find the y-intercept, you make x 0. When we make x 0, therefore our y, which is g of 0, will be equals to 2 over 0 plus 2. But we know that 2 over 0 is undefined. Okay, that's undefined, meaning that therefore there are no y-intercepts. No y-intercepts. All right. Let's find the x-intercept. X-intercept, we make y 0. We make y 0. All right, therefore 0 equals to x over 2. 2 over x, 2 over x plus 2. 2 over x plus 2. Now take the 2 to the left hand side. You'll have negative 2 equals to 2 over x. Multiply both sides by x to get rid of the fraction. That's negative 2x equals to 2. Divide both sides by negative 2. Therefore, negative 2x over negative 2 is equals to 2 over negative 2. The left hand side is x equals to, the right hand side is negative 1. Therefore, the x-intercept is negative 1. Now that we found our asymptotes, our intercepts, and we know what the shape is going to look like, let's draw the graph. Okay, let's start with the red one, which is the standard graph. The standard graph is very easy to draw. Okay, we go 1, 1, 2 half, 3 a third, 4 a quarter, and 2 half 2, a third, 3, and then a quarter 4. Now let's plot the points on the other side. There are the points on the other side. Okay, points on the other side. Now let's connect the points. Okay, connect the points. You don't have to draw this red graph. I'm drawing it so you have some perspective. Now let's draw the tail. That's the tail. Okay, on the other end, let's draw the tail as well. Okay, that will be enough. All right, let's connect the other points. Like I said, you don't have to draw this graph. We're drawing it for perspective purposes. Okay, let's draw the tail. Okay, there's the tail. Okay, let's let's leave the tail there. On the other end, we're drawing this as well. And let's leave the tail over there. And that's the graph of y equals to 1 over x. Now let's draw the blue graph. The blue graph should be easy to draw once you are able to calculate a few points. Okay, let's calculate those few points. When x equals to 1, y equals to 2 over 1 plus 2, which is equals to 2 plus 2, which is 4. When x equals to 1, y equals to 4. Okay, when x equals to 1, y equals to 4. X equals to 1, y equals to 4. Okay, let's find when x equals to 2. When x equals to 2, we've got 2 over 2 plus 2, which is equals to 1 plus 2, which is equals to 3. Okay, that is equals to 3 there. When x equals to 2, y equals to 3. There is the point. When x equals to 3, you get a fraction. 2 and a fraction. Alright, let's go to when x equals to 3. When x equals to 3, this is what you have. 2 over 3 plus 2. So that is equals to 2 and 2/3. 2 and 2/3. Let's plot that point. 2 and 2/3. So 2 and 2/3 will be somewhere here. 2 and 2/2. 2/3 is just less than 2/2 there. So that will be 2 and 2 over 3. 2/3 will be just over a half. So that should be somewhere there. Okay. Now let's plot the points on the other side. Here is one thing that will make it easy for you to figure out what's... Notice that your q is equals to 2, so let's draw that line so it gives us perspective. We draw that line so it gives us perspective. Here is the line, the asymptote. The vertical asymptote, the horizontal asymptote. Alright, so here is how the... Now, okay, the x-intercept is equal to -1. Okay, let's plot the x-intercept, -1. That is the x-intercept there. We don't have any y-intercept, so we don't have to worry about that. Okay, so that's the x-intercept. Now let's see what happens when our x is equals to -2. When our x equals to -2, we've got 2 over -2 plus 2, which is equals to -1 plus 2, and we know that that is equals to 1. So when x equals to -2, that is 1. X equals to -2, we have 1. Let's plot that point there. Okay. Then when x equals to half, -half, let's try and figure that one out. When x equals to -half, we've got 2 over -half plus 2, which is equals to 2 over -half. That is equals to 2 times -2 over 1. You flip that upside down, and that is equals to -4. So that is equals to -4 plus 2, which gives us negative 2. Negative 4 plus 2. Negative 4 plus 2 will give us negative 2. Yes, that gives us negative 2. So when it's close to negative half, we have negative 2. Negative half, negative 2. There is the point. Negative half, negative 2. So we've got 3 points. Okay, let's try and join them. Okay, when x equals to negative 3, okay, let's try and find that out. When x equals to negative 3, you've got, that is equals to 2 minus 2/3. So that is equals to 1 and a third. 1 and a third. When x equals to negative 3, that's 1 and a third. Okay, let's find 1 and a third. Negative 3, 1 and a third. 1 and a third should be somewhere here. That's the point. 1 and a third. A third should be somewhere here. All right, now let's connect the points together. It makes it easier when you plot the points. It makes it easier when your points are plotted. All right. Okay, let's make this big. Okay, we're joining the points. Okay, so this one will go right like this. And it will go like this. All right, on the other side, it will go like this. Okay. Okay, let's fix it a bit. Okay. Also approaches the axis. Okay, over here it will approach the axis like that. Now let's clean the board. And that is what the graph is going to look like. The graph is going to look like that. Now let's see what the graph calculator calculated for us. That is correct. We've got everything correct. Example number 3 says sketch the graph of, okay, let's change that to our favorite color. Sketch the graph of y equals to minus 4 over x plus 7. All right. Like always, we start with our a. Our a is equals to negative 4, which is negative, right? It's negative, so meaning that our graph will be on the second quadrant and the fourth quadrant. All right. Let's find the asymptote. The horizontal asymptote will be y equals to 7. Okay, the vertical asymptote does not change, will be x equals to 0. Okay, the y-intercept, you make x 0. When you make x 0, you have y equals to -4 over 0 plus 7, which makes this undefined, meaning that therefore no y-intercept. Next, let's find the x-intercept. For the x-intercept, we make y 0. Now when we make y 0, therefore 0 is equals to -4 over x plus 7. Take the 7 to the left hand side, that becomes -7 equals to -4 over x. Multiply both sides by x to get rid of the fraction. You have -7x equals to -4. Divide both sides by -7 to get rid of that and have x on its own. Therefore, -7x over -7 is equals to -4 over -7. The left hand side is x equals to 4 over 7, which is a small fraction. That's the x-intercept. Now let's draw the graph. Got the horizontal and the vertical asymptote. Okay, let's start with the horizontal asymptote and the shape of the graph. Okay, we know that the shape of the graph is going to be on the left hand, on quadrant 2 and quadrant 4. Let's mark those, quadrant 2 and quadrant 4. All right. Let's deal with the vertical asymptote first. The vertical asymptote is at 7. There is 7. That's the vertical asymptote. That will be the blue graph. All right, now let's draw the red graph. The red graph is very easy to draw. You don't have to do this. I'm doing this so that you have perspective and you are able to compare the two. All right, we've got 1, 1, 1, 1, 2 half, third, a quarter. There it is. Okay, the last one is on a quarter. All right, and on the other side, it's -1. Okay, you have this, you have that, and on a quarter, that's there. On the other side, we have half, a third, and a quarter. All right, let's join the lines. Okay, let's join the lines. Here is how we join the lines. And then the tails. That's enough. On the other end, let's draw the tail. And that will be enough. Let's join the points. And the tails. That will be enough. Tail on the other end. That will be enough. And now let's draw the graph. So here is how we draw the graph. We know it's going to be on this quadrant and that quadrant. The question is, what then do we have when x equals to okay, so the graph is going to go basically like this, and like that. So when x equals to 1, when x equals to 1, y equals to -4 over 1 plus 7, which is equals to -4 plus 7, which gives us 3. When x equals to 1, y equals to 3. X equals to 1, y equals to 3. X equals to 1, y equals to 3. When x equals to 2, let's figure out. When x equals to 2, y equals to -2 plus 7, which is 5. Alright, when x equals to 2, we have 5. Y equals to 5. When x equals to 2, 2 is over here. Y equals to 5. That's the point there. When x equals to 3, okay, let's see. When x equals to half, yes, let's find the half. But when x equals to half, therefore, okay, -4 times 2 over 1, that's -8. So that's equals to -8 plus 7, it gives us -1. When x equals to half, y equals to -1. When x equals to half is over there, y equals to -1. Let's plot that point. That will be enough on this side. Let's join the points. When x equals to 4, let's do that one. When x equals to 4, we've got -1 plus 7, which is equals to 6. When x equals to -4, y equals to 4. When x equals to 4, y equals to 6. 4 and 6. There we go. 4 and 6. 4 and 6. There. So this is how the graph is going. Let's try and join the graph. The points of the graph. Let's join the points. Alright. Now the tail will go like that. Doesn't touch, but it goes towards the axis. And on the other side, this is how it goes. Okay, it will go like this. Doesn't touch, but goes towards it. Okay, on the other end, let's plot the points. On the left hand side, when x equals to -1, let's see, when x equals to -1, we have -4 over -1 plus 7, which is equals to 4 plus 7, which gives us 11. Okay, when x equals to -1, we have 11, negative 1, 11, negative 1 and 11, that's negative 1 and 11, negative 1 and 11. Okay, when x equals to negative half, when x equals to negative half, negative half, okay, 4 times negative, negative 4 times negative, but divided by negative half, it's equals to negative 4 times negative 2 over 1, which is negative 8. So that's negative 8 plus 7, which gives us negative 1. Y equals to negative 1. When x equals to negative half, y equals to negative 1. When x equals to negative half, y equals to negative 1. Negative half and negative 1, that's where it tailors off. No, that should be no. No, sorry about that. It's not correct. When x equals to negative half, we have negative 4 over negative half. That is equals to negative 4 times negative 2 over 1, which is equals to positive 8. 8 plus 7 is equals to, take out a calculator, 8 plus 7, 8 plus 7, that is equals to 15. 8 plus 7 is equals to 15. So when x equals to negative 1 half, your y equals to 15. Where is 15? 15 is way up there. So it's going tapering up there. Alright. When x equals to, it's outside of range for this axis. Okay, so it goes this direction. That direction. Alright. Alright, when x equals to negative 2, when x equals to negative 2, we've got 2 plus 7, which is equals to 9. 2 plus 7 is equals to 9. When x equals to negative 2, we've got 9. Negative 2 and 9. Negative 2 is there with 9. Negative 2 and 9. Negative 2 and 9. There is negative 2 and 9. Then when x equals to negative 3, okay, when x equals to negative 4, when x equals to negative 4, we have, that is equals to 1 plus 7, which is equals to 8. So it's going down and down and down. Okay. When x equals to negative 4, here is negative 4, we've got 8. Negative 4 and 8. There is the point. So it tapers that direction. Now let's connect the dots. Oh, sorry about that. Let's connect the dots. And then the tails. There is the tail. On the other side, the tail goes like that. Okay, let's clear the board. And now let's check what the graph calculator drew. And that is a correct graph that we have over here. Let me show you the correct graph. That is the correct graph we have over here. Now for example 4, the following graph shows a hyperbolic equation of the form y equals to a over x plus q. Point A is shown at negative 2, 5 over 2. Calculate the values of a and q. That should not be difficult. We're basically finding the equation of the graph. All right. Y equals to, let's take it back to my favorite color. Y equals to a over x plus q. The graph has been shifted 2 units up. Look at the asymptote. The graph has been shifted 2 units up. The graph is shifted 2 units up. Therefore, q equals to 2, meaning that therefore y equals to a over x plus 2. Next, point negative 2, 5 over 2. Point negative 2, 5 over 2 lies on graph, lies on y. Therefore, we substitute. The y is negative 2. Therefore, negative 2 equals to a over the, therefore 5 over 2, that's the y coordinate. The y coordinate is on y, equals to a over the x coordinate is on x plus 2. Therefore, take the 2 to the left hand side. 5 over 2 minus 2 equals to a over 2. Negative 2, a over negative 2. All right, which gives us what? Okay, therefore that's all over 2. Let's fix the fraction. 5 minus 4. 5 minus 4 equals to, sorry about that, equals to negative a over 2. Equals to negative a over 2. Therefore, 1 over 2 is equals to negative a over 2. Multiply both sides by negative 2 to get rid of the minus sign in the fraction. Multiply by negative 2 over 1 times 1 over 2 equals to a. Therefore, negative 1 equals to a. So your q is equals to, therefore, your a is equals to negative 1 and q equals to 2. Meaning that therefore the equation is y equals to negative 1 over x plus 2. Now the last question says, given the following graph, identify a function that matches each of the following equations. All right, we've got 1 on the negative side on quadrant 2 and 4. So let's mark the quadrants. That's 1, that's 2, that's 3, and that is 4. So 1 that is on the quadrants negative 2 and 4. is one with a negative a. So what will that be? K of x will be equals to negative 2 over x. So that's number C. K of x is number C. K of x, that's number C. All right. We're done with that. Okay. Now, these ones will depend on your A. If your A is bigger, then it will be removed from the axis. So the one with the smallest A, okay, we've got 2, 4, and 8. The one with the smallest A is h of x. So h of x is number A. So that's number A. So that's A there. So that's A. The next one, g of x, has got 4 as your A. So that is number B. That is number B. G of x is number B. And the last one, which is supposed to be number D, is 8 over x. Number D, 8 over x, that is f of x. And that's how you match the equation with the graph. We've come to the end of this video. Thank you very much for watching. See you on the next one. Bye.